You have x to the half and x to the half. When the base is the same, we add the exponent. So x to the 2 halves or x to the 1, just 5x. We're not going to have a square root. Even though it says put it in radical form, we're not going to have one. Whereas when you look at 12, 12 says that we are taking 81 to what power? What's our fractional? 1/3. That means I'm taking the cube root of 81. And I know 81 is what times what? 9 times 9. So I might even start it that way. Okay? And I'm just going to do my numbers separately. And then I'm going to have s to what power was it? 1/3. And another s to the 5/6. So you kind of want to do the variables separate from the numbers. If I have s to the 1/3 and s to the 5/6, my common denominator should be 6. I should have had, how many 6? 1/3 is 2/6, right? So 2/6 plus 5/6 gives us s to the 7/6. But now this cube root of 81. 9 times 9 is really, if we're writing out all our factors, 4 3s, right? So the problem that some people thought is they find the cube root of 81. Well, there isn't a nice cube root of 81, but there is a nice cube root of 27. 3 times 3 times 3, if that's the cube root of that, that is simply 3. And then you are left with this cube root of 3. So it's an ugly problem, and we're still not done because this isn't written as an exponent yet, right? So when we take a look, we have 3 times the cube root of 3, because this really was 27, right? 27 times 3. And then we have our index here being 6 and s to the 7. So next week on Thursday, we have a quiz covering all this stuff that goes through the lessons that we're going on this week through G7. And you will be asked radical form and exponential form and to simplify and looking at these worksheets that we've been doing. It'll be all that kind of stuff. Right now, if you would please read, Maria, the vocabulary part. Keep going. So this is going to be key to what we talk about being simplified. Under that radicand, there's no perfect squares that you can factor out. So if I have something like the square root of 50 not simplified, whereas if I have something like 5 square root 2, that is in simplest form. You can have no fractions, right? So this one says it's simplified. This one says it is not simplified. Someone said, yeah, but this is a fraction. The radicand can have no fraction. So underneath that square root cannot be a fraction. So these are different, okay? And then it says that there are no radicals in the denominator of our fraction. So you can have a fraction. It's just that the square root, the radical, cannot be in that fraction, okay? So those are going to kind of be the key things to look back and see if they're simplified or not. So this first one they give us, they said the square root of 160. This is what we've been doing on that worksheet, on that 209 and 204. 160, 16 times 10. Square root of 16 is 4. 4 square root of 10. Is it now simplified perfectly or completely? Yes, because 10 is 5 times 2, but neither of those are perfect squares that we could simplify. So it says simplify the following. Square root of 72 and cube root of 16. Square root 72. What's a perfect square that goes into 72? Okay, let's go bigger. 9 times what did you get? When you go 72. You went 9 times 8. Did anyone go larger? You could have gone 36, right? 36 times 2. So if you go with the bigger square root, less factoring. Is this one still going to get you the same answer? 9 times 4 times 2? Yes. Both answers for this are going to be 6 square root 2. So now let's do the cube root of 16. Gavin, how are you going to start cube root of 16? How are we going to factor 16 a perfect cube? Do what? 8 times 2. So if we are doing 8 times 2, Brecken, the cube root of 8 is 2. And we are going to be left with the cube root of 2. Okay, so kind of what we've been doing on those worksheets and practicing. We're just going to get more of them. Same thing with our variable parts. So, Hayden Zimmerman, would you please read on the top of that next page? Sometimes
you can simplify radical expressions that contain variables. When dealing with square roots, an exponent that is divisible by 2 is a perfect square. When dealing with cube roots, any exponent that is divisible by 3 is a perfect cube.
So key thing when we are looking at those, we want to look for when it's square roots that your exponent is divisible by 2. Cube roots, the exponent is divisible by 3. So this one is telling us square root, and we notice it's a 7. So we have to factor it so it's divisible by 2. And the key thing to remember is that you can break down those variables. So n to the 6th, and this would be n to the 1st. And for some of you, if it helps you to put that 1 in there, put the 1 in there. Someone said, why are we going 6 and 1? Why not go like 3 and 4? Well, 4 is even, but you want to go with the largest number that adds to the 1, so you're left with that. So we're going to split it down. Square root of n to the 6th, square root of 9 gives us the 3, n to the 6th. We're dividing 6 by 2 and giving us 3, and we're left with this last part. Questions as you are looking at that. Again, simplifying those if it helps you to write it as a fraction first. But remembering that's what that index is telling us. So next page down in your notes. 243. Now you have your calculators, right? So 243. Oh, looks pretty nice. Divisible by 3. So what perfect square when you divide by 3, what do you get? 81, perfect square, right? So I have 81 times 3. X to the 5th, we are going to break it down as x to the 4th times x to the 1st. Why 4? Because this is an index of 2 out here. And 4 plus 1 is 5. So the square root of 81 is 9. Square root of 81. And we also have the square root of x to the 4th. So those two we can find. That is 9x squared. We cannot find the square root of 3 or x. So our final answer will be 9x squared, the square root of 3x. In the next one, negative m. It is a square root. So when I look at this m to the 9, I want to go with m to the 8 and m to the 1st. Because 8 is divisible by 2. Mallory, if we're looking at 80, what perfect square maybe? 4. 4 times 20. Anyone go bigger than 4? You could go 16. If you didn't recognize that, right? If you didn't recognize that, then you just got to factor this one more time, right? To 4 and 5. That's all right. So this is like a negative 1 out in front of m. So we have a negative 1. We're going to put all of our numbers. So we have square root 4 and square root 4. So that's like the square root of 16. We have the square root of m to the 8th. We have the square root of 5 and m. The reason I'm keeping the 5 and m together is I can't simplify that. Okay? So I have negative. Square root of 16 is 4. Square root of m to the 8th is m to the 4. Remember, this m to the 8th, what does that mean if you have the square root of m to the 8th? That means m to the 8 over 2, right? 8 divided by 2. I did. Square root of m to the 8th. There we go. And then we have the square root of 5 for our answer. So kind of like those worksheets that we've been doing, right? We got a few more, as we are simplifying. So now they give you some with multiplying with your radicals. So if we are multiplying, this is kind of like our worksheet, right? That 209 that you were looking at. We have 2 times square root t times 3 square root of 14t squared. It says multiply the whole numbers. Use the multiplication property of square roots. So we are multiplying our 2 and 3 together and gives us 6. 7 and 14. Some people don't like to multiply those. They multiplied and got 98. Could you have factored this right away as 7 and 2, or 7 times 2? Yes. Because then if you have underneath your square root, the square root of 7 times the square root of 7, remember that equals just 7. Because the square root of 7 times 7, that is 7 squared. And these two undo each other. The square root, that radical, and the square gives us just 7. Some people prefer to go square root of 49. No problem. 49, square root of t squared gives us 7t, leaving the square root of 2t underneath there. So, they give us one with cube roots and one with square roots. 32, if we are looking at cube roots with 32. What perfect square are we looking at that goes into 32? Perfect cube. 8, right? So we're going to write this as the cube root. Now, cube root of 32 and cube root of 20. We might want to just multiply those together. What's 32 times 20?
40.
Is that kind of nice that we want to multiply those instead of breaking it down? Because now, what's a perfect cube that goes into 640? 64, right? So this is the cube root. That's why memorizing those first 5 cubes is 64. And then you also have the cube root of 10, right? So 3 times the cube root of 64 is 4 times the cube root of 10. So the answer that they are looking at should be 3 times 4 gives us 12 times the cube root of 10. Now, here's a mistake that some of you, I can't tell that this is an index. And if I can't tell this is an index and you have like 123 square root of 10, that's a different answer, right? So you need to make sure I can tell that that 3 is smaller an index. I don't know if it means making your square root larger. Some of you, that's what I wrote on your notes on the homework you handed in. I couldn't tell where your roots were. And we are not writing in that 2 usually, okay? That's understood. So as we look at this next one, we're going to start multiplying out in front. So as we multiply, the 7 times 3 gives us 21. 20 times 5 gives us 100, right? X to the first and x to the fifth, x to the sixth. This one's even nicer, isn't it? 21 times square root of 100. 10, square root of x to the 6th, x to the 3rd. Remember, when you have this with a variable, this really means x to the 6th divided by our index 2, right? That's how they got that x to the 3rd. So we should be looking at 210 x to the 3rd. So this next part, we are going to be simplifying as you look down at those. And I want you to start. The third one, all 4 of these are indexes 2. So when you look at the variable part, remember that anytime you have exponents with variables, you can always rewrite those and you're adding those 2 variables. So you want one of them to be divisible by 2, and you want it to be 1 plus, because then it's usually, if it's an odd power, you want to go 1 plus, and in this case 2. Here I have c to the 7th, so I'm going to go c to the 6th and c to the 1st. Because I can find the square root of n squared. So that first answer, Soren, what'd you end up with? Give it a shot. Tell me.
Oh, I said 10n.
Does it make sense that we're going to have 10n and then this square root n? So we're not going to leave it cube root n, okay? So when I did 525, did 25 go into that? How many times does 25 go? 21 times. So 25 times 21. The reason I broke it down to 7 is to 6 and 1, is that I always want to add the 2. So if I would give you the square root of x to the 9, what should I break it down to? X to the what? X to the 8 and x to the 1. Does that make sense to everyone? Caden? Yeah. Yes? So when you're looking at those, that's what you got to be careful for. So here we are going to be looking at the square root of 25 and the square root of c to the 6th. 5c to the 3rd. With the square root of 21c. Questions? All right, so let's go to those last two. 24 times 32. Let's multiply. I mean, you could factor, but 24 times 32. You're going to have your calculator. So we have how much? 24 times 32 is how much? 768. Now I'm looking at 32 up here and I'm looking at 24. And I know 4 goes in here and 4 goes in here. So what should go into this if 4 goes into both those? 4 times 4 is 16. So on your calculator, 768. 16 times
48.
So can I go bigger than 16? I could have gone with 64. 64 times 12. And this may be one that when you looked at it, you might have even wanted to factor this, because like this is a huge number, 768, right? And if you do this, you're only partway there, right, with the 8. And now you got to factor 12, right? Is 4 times 3, and that has to stay underneath the square root, a and b. So you have 8 times 2, which is 16, with the square root of 3ab. As I look at this problem, this is one where if I was looking at this one, I might have factored the 24 right away and factored that as 4 times 6. And I might have factored 32 as, if I'm looking at 32, I might have factored it as perfect square, 16. And that might help me to break it down a lot easier to find those perfect squares, because I can find the square root of 4 and the square root of 16. And this is going to be the square root of 12. So there's many ways of doing this, right? This one, the numbers are a lot better. -4, -8 times 4 gives us, you start multiplying, a negative 32. Underneath our square root, I get 15 and 5. 15 I might want to factor is 3 times 5, and then I have another 5. The reason I'm factoring is if I have these two 5s, I know I can, the square root of 5 times 5 is simply 5. I have h to the first and h to the first, which gives me an h to the second. And I'm going to end up with k to the, I'm going to leave this as k to the second and k to the first. Do you see why I want to leave it as k to the second and k to the first? Because I can find the square root of k to the second. So we have negative 32 times 5. What else is going to be outside of our square root? H to the first, and I don't have to put the 1 there. K to the first. Left underneath our square root, I still have this 3 and this k to the first. And a lot of times we don't put that 1 in there. I will not mark it wrong if you put a 1 there. But a lot of times you're going to see that answer looking without the 1s. If you put the 1 in, I am not going to mark it wrong. Okay? Kyler.
I factored a different way.
No problem. You can do that. There's more than one way of factoring it, right? You could have gone 25 and 3.
Yeah, it took 55, got 75.
Yes. Same thing as we are looking at, right? All right. So your homework assignment is in your textbook. And you are simplifying as you look at those.